let's look at interpreting and comparing rates of change now. Okay, so in this part, we're going to show the rate of change into different functions. And then we're going to learn how to interpret, or better yet, read the graph and compare the rates of change. So let's read the problem together. It says a biologist studied the growth of two different trees over a 5-year period. At the beginning of the study, she measured each tree's diameter. That means when you cross-section the tree, you're actually opening the tree up and you see like a circle from the tree, like the insides of the tree, and you see all its rings. The biologist took the same measurement each year to determine the growth. The red maple in her study had a starting diameter of 4 inches. The diameter grew at an average rate of 0 3/10 inches per year. The graph on the right shows the growth rate of the silver maple tree. Which function has a greater rate change? Okay, so let's talk about what a rate of change is. We learned previously that in our previous slides that our rate of change is where our initial input is and what our x value or our horizontal value is and our vertical value is over each other. So we found out what our fraction is depending on how fast this arrow or this line keeps going up on this number line. In this case, our rate of change for these functions is the growth rate. Dig deeper. What is this problem about? Our biologist studying two different kinds of trees over a 5-year period. So she's looking at two different trees and seeing how each of them grow. Now, what are we trying to find out? What is this problem looking for? And again, the hint is it might be a verb that's telling you to do something, or it might be a question. In this case, the problem is asking which function has a greater rate of change, meaning which tree grows the fastest, which tree grows faster than the other. Okay, so we're looking at the function of one tree, then we're looking at the function of another tree, and then we're going to compare the two different graphs to see which one grows the fastest. So what information is important? That the biologist took the same measurement every year, so we're going to count by 1 year and we're going to have a different measurement. We know that her red maple tree has a starting diameter of 4 inches. That's our initial output for our red maple tree. As the diameter of that red maple tree grew at the average rate of 3/10 inches per year. That then makes me ask the question, well, what about the silver maple tree? Well, it says the graph over here on the right shows the growth rate of that silver maple tree. So this graph is also going to be important data that I'm going to need. So I run into the problem of them giving me words, this word problem as a part of my data. And then they give me a graph for the second part of my data. I have two different types of data here. One is the words, okay, and separating the words to form my data. And then I also have this graph in order to read my data. So here's what we're going to do. We're going to convert that into a table. Once we can convert it into a table of values, then we can graph the data so that we can compare a graph for the red maple tree to a graph of the silver maple tree. So in the second part, it says, make a table of values on page 64. At the beginning of the study, year 0, the diameter of the red maple tree is 4 inches. So again, this is my X and this is my Y. And then we found out what year 1 was. It was 4.3 inches. She recorded year 2 data as 4.6 inches. Then she recorded year 3 data. The tree was 4.9 inches. And then for year 4, we recorded that the diameter of the tree was 5.2 inches. And for year 5, we recorded that the data for the tree was 5.5 inches. It grew 0.3, our growth rate is 0.3 inches per year. So what happened was we added 0.3 to the first year, 0.3 to the second year, 0.3 to the third year, 0.3 to the fourth year, and 0.3 to the fifth year. Then we use these values, our x and our y, to make this table on our graph. And here's how we did it. In year 0, we already measured that it was 4 inches. Know that our first coordinate is going to be 0, 4. Then I'm going to take a look at year 1 and put in my x value. My output is 4 3/10. So that's going to be my y value. Again, our x value is the top row, our y value is the bottom row. Then I'm going to plot my next point. My x value is 2, and whenever my input is 2, my output for this case is going to be 4 6/10. My next plot or coordinate is going to be 3 4 9/10. My next coordinate is going to be 4 5 2/10. And my final coordinate is going to be 5 5 5/10. Okay? When these are plotted, my 0, 4, 1 and 4.3, 2 and 4.6, 3 and 4.9, 4 and 5.2, and 5 and 5.5. If I draw a line through it, a consecutive dots, okay, this is going to show me my graph for my growth rate for my red maple tree. So now let's take a look at those two graphs and compare the rates of change for both functions. Write the ordered pairs. I'm on number 2 on page 65. It says write the ordered pairs for the points that show the initial value of each graph. Okay, so again on page 65, we write our initial value for our silver maple tree. And we see that our value for our silver maple tree is 0, 2. The value for our red maple tree, our initial input is 0, 4. What do these initial values represent? They show our diameter of the tree at the start of our biologist study. In year 0 is where she starts taking her data. And her data for the red maple, again, is 0, 4, and her data for the silver maple tree is 0, and right in between the 2 and the 4 is where that plot is, so that's our 3, okay, because we're skip counting 2 through 10, so it's 0, 3. So on to our next question. It asks fill in the blanks to describe the rate of change for both functions. We know that the red maple graph is the vertical change over the horizontal change. So that means that it's 0, 3.3, meaning that red maple tree grew 0.3 inches per year over 1. Silver maple tree starts off at 3 and grows to about 3.5. It doesn't quite hit that 4. It goes to about 3.5. It's in between that 3 and that 4, and it's right smack in the middle. So we're going to say it grows about 0.5 inches per year. So when we're looking at the rates of change in each problem, we're looking at the growth of the tree's diameter in inches per year. So the red maple tree grew 0.3 inches per year. The silver maple grew 0.5 inches per year. Now it asks, which function is the greater rate of change? And what does it mean in this context? So what this problem is asking is, which tree? Is it the red maple tree or the silver maple tree that has the greater rate of change? Meaning, is the silver tree the one that grows the fastest, or is the red maple tree the one that grows the fastest? And in this case, it looks like the bigger number is the 0.5, the 5/10 over 1. So that means that our silver maple tree grows the fastest. And that means that the silver grew faster than the red maple tree. So what you're doing is, with your rates, you're again finding that vertical change from the horizontal change. So when I look at my vertical change for my red maple graph, my vertical change is from my first year to my second year, and it looks like it grew 0.3 from here to here. And then my horizontal change for my red maple is from the initial point, the initial starting point, to where it is right now, and that's 1. So I put that 0.3 over 1. And for my silver maple tree, my initial starting point for my vertical change is 3 to 3.5. So that's a 0.5, a 5/10 change from year 0 to year 1. And then I'm looking at my vertical output, which is from this year 0 to year 1. That change is 1 unit. Okay, that gives me my answer for my vertical and my horizontal change for my silver maple graph.